Our next lesson is called Key Features of Functions Day 1. Graphs of functions have many features that we want to become familiar with. The names of these features are often very descriptive. So in our first example, we're going to look at the function y equals f of x shown on the graph below and answer the following questions. First, we want to find the minimum and maximum values of the function. State the values of x where they occur as well. So minimum value, minimum means lowest. So here we're looking for the lowest y. So when I look at the graph, I'm looking for the lowest y value, which is here. This would be my minimum. So the minimum value, the lowest y, is -6. That's occurring at x equals 2. Next, maximum value. So maximum value is looking for the highest y. So if I look at my graph, that's going to be here. This is my max. The y value there is an 8. So my maximum value is 8. That's occurring at x equals -5. So minimum and maximum sound exactly like they should. Minimum's the lowest, maximum's the highest. Next should be one that you're familiar with. Part B says, what is the y-intercept of the function? So we want to know where it crosses the y-axis. So when I look at the graph, it's crossing the y-axis right here. This is your y-intercept. Your y-intercept is located at 0, -2. It also says, what is the x value at any function's y-intercept? Well, if you're a y-intercept, you're definitely going to be on the y-axis. And no matter where you are on the y-axis, your x value is always going to be 0. Next, in part C, it says circle and state the x-intercepts of the function. So we're going to circle and state. We are looking for the x-intercepts of the function. So to take note of that, if we want the x-intercepts, we want where it crosses the x-axis. These are also known as zeros of the function because they are where f of x, or the function, is equal to 0. So there's a difference between x-intercepts, which are points on the graph, and zeros, which are just the x values. So we're going to state the difference of these below. First, let's go find them on the graph. We want where they cross the x-axis. So we have that happening here and here. So for x-intercepts, we would have the point -1, 0 and 8, 0. X-intercepts are referring to points on the graph. However, if you're asked for the zeros are only going to be the x values, the places where the function is equal to 0. So we would write x equals -1 and x equals 8. And this is referring to where the function is going to be 0. Next, D. Would you characterize the function as increasing or decreasing over the interval -5 is less than x is less than 2? So if I go up in here and I look, we're talking -5 to 2. So I'm going to highlight the portion we're referring to right here. Would we describe that as being increasing or decreasing? Well, when I look at that As the x values are increasing, the y values are going down. So that means that this section of the graph should be decreasing because the y values are going down. Next, it says give one interval over which the function is increasing. So we want to look at the graph and see where it would be going up. So if I go back with my highlighter, kind of see this portion here and this portion here. So I have some choices. They only wanted me to give one interval. Since this is our notes, we'll list both of them so you understand that you had choices here. When you're giving the interval over which something is increasing or decreasing, let's write down that we only want to use x values. So we have a couple choices here. The first section that I graphed is going from an x value of -8 to an x value of -5. So we'll write -8 is less than x is less than -5. That's the first interval in which it is increasing. The next one where it's increasing, we can see goes from a x value of 2 to an x value of 9. So we'll say or 2 is less than x is less than 9. And then underneath, notice that this is not inclusive. We are not including the place where it ends or where it turns. That's going to be addressed in the next section. It says state the coordinates of the turning points on this function and label them as either a maximum or a minimum. So the turning point, let's talk about what that even means. Turning points are where the graph changes direction. So when we go back up and look at the graph, you can see in the blue portion we highlighted, it was headed up. Then all of a sudden it hit a certain point and it turned around. So that would actually be our first turning point, which was -5, 8. That coordinate, if I look at it, it's said to label as a min or max, is the highest it goes on the graph. So this one is a max. Then if I look at the graph again, where I kind of highlighted in orange, it was headed down, then all of a sudden at a certain point, it changed direction. That coordinate is 2, -6. And when you look at the graph, you can see that's the lowest point on the graph. So this one is a min. And then lastly, it says give the interval over which the function is negative. So I'm going to highlight that word negative. And it's going to correspond to where we highlight on the graph. So negative means where the function is less than 0. So when we look at the graph, that means we want to look at all the places where the function would be less than 0, which is going to be this bottom portion of the graph. That's where the function would be negative. So that's happening when we look at the graph between this point right here at x equals -1 and this point right here at x equals -8. Anything above that, or sorry, +8. Anything above that would be considered positive. So it's negative wherever it is below 0. And that's happening from -1 less than x less than 8. So in summary on the bottom, it's really important that we discuss what we're supposed to use when we're answering the question of key features. So which key features require a coordinate, a value versus an interval? So the key features that would require you to write down a coordinate as your answer would be the y-intercept, the x-intercept, and also any turning points. All of those answers should be completed by writing down a coordinate. The key features that require just a value were the ones we started with, minimum and maximum, but also the 0 or zeros. Remember, those were only the x values. That was a single value. The key features that require an interval would be any places where the function is increasing or decreasing, as well as where the function is positive or negative. So we kind of used one graph there to go over all of the key features that you could be asked about when looking at a function.